physics lecturer. So in this class we will be studying about Ohm's law. Okay. So before understanding Ohm's law, we need to know the difference between what is called as the conducting materials and the insulating materials. Can you just answer me what is the conductors and what are insulators, and that will suffice the difference? Well, so to get that, let us first try to understand the conductors and insulators. Conductors and insulators. In conductors, we have number of free electrons. These free electrons are comparative to insulators, they are little excess. So that means the conductors are the materials which have excess number of free electrons. That means excess free electrons are present. So whereas in case of insulators, the number of free electrons are very much limited, or in other words, they do not have, okay, do not have free electrons. Free electrons. What is the role of these free electrons? When the electrons are free, what happens is they start conducting. So the second difference you can say, that is, the conductors are the substances which allow the passage of electric charges through them. That means they allow the electric charges to flow through them. Whereas for insulators, they do not allow these electric charges to flow through them. Why? Because they are very much limited. In other words, practically zero the free electrons. So these do not allow free electrons or charges through them. Okay, fine. So these are the main two differences. So can you just give an examples? So the example you can take it as example for conductors. You can take metals and human animal body. Okay, you can take this. Whereas for insulators, the examples will be, you can take it as the wood as an example, wood, glass and etc. Okay, those substances which do not allow the flow of electrons, you can take it as insulators, and you will have a number of examples. Okay, so wood and glass. And now here what is important is the concept of free electrons. If you have a free electron, then your substance can conduct through that, and if you don't have free electrons, the substance cannot conduct through that. Okay, so I am sure you are aware of this thing. So having known this, and also one more important thing, that is you can say there's another important difference, that is if you supply some electric charges to conductors, or if you give them, they distribute themselves over the entire surface of the conductor. Whereas if you give to the insulator, they do not distribute. They accumulate at that particular place itself. They don't move around. Okay, that's the property of this conductor and the insulators. Fine. Having understood this difference of conductors and insulators, now we are trying to understand what is Ohm's law. Okay, because Ohm's law is valid mainly for conductors, because it has to deal with the free electrons. Yeah. Now, so Ohm's law states that when you have a conductor, okay, so if you supply with some potential difference, so I choose my conductor like this. I choose a conductor like this. Now I supply it with some potential difference. Okay, so I'm just taking a material like a rectangular shaped material. You can take it as some metal. Okay, so if you are supplying here at the positive potential moving in this direction, so the current is in this direction. Okay, this is the potential difference V, and now this will be your negative potential side. Okay, so this is the terminal A and this terminal B, let's say. Yeah, so when you supply the potential like this conducting material which has the number of free electrons, okay, number of free electrons, okay, you can have a number of free electrons as distributed over the entire material surface. Yeah. Now, because of the application of this potential difference, these electrons, they get accelerated towards the opposite potential. That means where will they move? So this is the positive potential. These electrons tend to move this direction. Let us highlight with a different color. Okay, so these electrons tend to move towards this direction. That means similarly this also tend to move here, this also tend to move here. Okay, this process of movement of electrons from B side to the A side continues so long as there is a potential difference applied across the ends of the conductor. So I chose a conductor which is AB and applied a potential difference of V volts. Now obviously there is some current flowing through that, and this current is in proportion, to the potential difference applied across the ends of the conductor. So Ohm's law states when you supply through a potential difference to a certain conducting material, the amount of current conducted through that particular material will be in proportion to the potential difference applied to that. Okay. Now, how is it proportional? How it is proportional? That is to be understood. Now, according to Ohm's law, V is proportional to I. V is proportional to I. What is this V? V means the potential difference applied. Okay, applied. Where do you apply it? Apply at the ends of the conductor. Now, what is this I? I is called the amount of current. Okay, amount of current that is produced. Okay, the amount of current that is flowing or produced, you can say. Now, what is this proportionality constant? This proportionality constant is called resistance. Where R is called as the resistance. Okay, this is a proportion. R is called the resistance, called the proportionality constant in Ohm's law. Now, this Ohm's law is valid when the physical condition is maintained. What is the physical condition required? Okay, we mainly speak about the aspect of temperature. If the temperature around this region of the conductor is maintained, then this Ohm's law is valid. If it is not maintained, Ohm's law is not valid. The reason is very simple, because if you don't maintain the temperature, these electrons get influenced by the external temperature. That means they get heated up. Because of that energy, they already started, even before applying the potential itself, they start accelerating. Okay, even in the presence of potentials, they start accelerating, but you may not get the accurate value of the constant value, that is resistance, or the value of current. Okay, so this kind of variation does take place. To avoid that, we need to go for a physical condition of constant physical condition, that is temperature has to be kept constant. And another reason is the mechanical. Another thing very important here it is the mechanical strain. This condition also has to be kept constant. Okay, so I am sure you have understood what is Ohm's law. Let me revise it once again. So Ohm's law states for a given conducting material, when certain potential difference of V volts is being applied across the ends of the conducting material, the amount of current generated or produced is directly proportional to the potential difference. And how it is proportional? It is proportional as R as a proportionality constant. Okay, V is proportional to I, we say, or sometimes we also refer I is proportional to V. Okay, in this case, if you are referring, this proportionality constant will not be like I will be is equal to V by R. This is the relation here. But if you are referring in this way, this will be V is equal to I into R. This is the relation. That means here the direct proportionality, but here it is the inverse proportionality. Okay, so keep this term in mind. It's very important. Now, as I told you, the physical condition is very important. Suppose if you have a set of values of the values of potential difference and the current, then you can plot a graph that indicates you the value of resistance of that particular conducting material. Fine. Let's look into one of such graphs. Okay. So suppose if I give you a table of table of values having I value in amps, okay, then V value in volts, amps, volts, and R value. Okay, what is this R value? The resistance value. The resistance value. What is this R value? How can you calculate? You can calculate it by V by I. Okay, so I am sure. And this is indicated in terms of ohms. Okay, this is indicated in terms of ohms. Now, if there are if the values, let's start with the basic value from first unit. Okay, if the current, okay, the current read through the ammeter in this experiment is 1 amp, then the voltmeter will read a value of 2 volts. In such a condition, if you calculate the resistance value, it will become how much? 2 by 1 is 2. So the 2 ohms is the resistance of a particular material. Now, you slightly increase the value of the current. So let's say I go for 1.5. I go for 1.5. When I go for 1.5, will my potential difference be same? Certainly no. That means it's in proportion to that. So therefore it will be, let's say 3 volts. 3 volts. So when this is 3 volts, and again I take back 3 by 1.5 is nothing but 2 ohms. Okay. So like that, if you go for 2 amps of current passage through the conducting material, the potential difference is 4 volts. So again you get 2. Okay. So you can take a number of values. So these values 2 in the resistance indicate that the resistance is constant. Resistance is constant. So that's what I told you. This is a resistance constant, right? Constant resistance. Okay, this is a constant value. Now it's very clear. That is, I'm going to plot the graph. I take V along the y-axis. V is in terms of volts along the y-axis, and I take I value, the current value along x-axis. Okay, so this is in amps. Okay, this is in amps. So I take it along x-axis. Now this is a 0, right? This is the origin. Now if you substitute these values, let's say somewhere for I, this is the 1. Okay, then at 1 the V is in 2. Let's say this will be the point. And when it is 1.5, let's say 3. This is the point. This is 2. This is 3. This will be 1, 2, 3, and goes on. So if you go similarly, you may get points like this. Okay, these things indicate you the value of resistance is constant, right? The value of resistance is constant. That's what you have got it here. And you can draw a slope here. Okay, slope. What is the slope? dy by dx. Okay, what is the dy by dx? Take V by I. V by I is equal to this is what the dy by dx value, and this is the value of resistance you can get it. And this is for a particular temperature, T temperature. Okay, particular T temperature. Now, suppose I take another conducting material, which is not the same, which may be having a slightly different resistance value, but I don't know the value of resistance. How to find that? You maintain at a different temperature, which is not same as your previous experimentation. So when you take that one, suppose if this is initial T1, and then I take another conducting material or the same conducting material at a different temperature. Let's say, okay, I take the same material but a different temperature. So then again, if I plot a graph, I will get again that also straight line. Okay, that also straight line, and you can also again take the slope and find the value of R2. R2 will be now V2 upon I2. V2 upon I2. Okay, don't get confused. So here you can take it as V1 upon I1. V1 upon I1 is equal to R1, and for R2, V2 upon I2 for a temperature of T2. Okay, so these are the values. Now let's sum up once again. That is, Ohm's law states for a given value of conductor, or for a given particular type of conductor, the potential difference we applied across the ends of the conductor, the amount of current generated or produced is in proportion with the potential difference, and that proportionality constant is called the resistance of the material. And this resistance is simply the obstruction offered to the flow of electrons through the conducting material, and this is in proportion of as it is shown here, and the graph will be indicating the resistance is constant. Okay, I am sure you have understood this thing, and thank you.